Hi class, this is Neil, and this is the third and final video of lesson 4. In this video and in the example we'll go through, we're going to take a look at when we're given a terminal side or a point on a terminal side, how do we find theta or our angle using what we know about a reference angle. All right, so let's take a look at the example. Circle O is centered at the origin. The terminal side of angle theta intersects the circle at the point 8, -15. We need to determine to the nearest degree the measure of theta. All right, so let's kind of label what we know in this diagram at right. So first of all, I'm going to draw on that point 8, -15. Now that's a positive x value and a negative y value. So that tells me I'm in quadrant 4. So positive x values are this way, negative y values are that way. So let's estimate that point to be around there. Now, again, this doesn't have to be perfect. This is just a diagram to help us visualize what's happening in this problem. All right, so that's where the terminal side of the angle intersects. So I'm going to draw the initial side of my angle. Here's the terminal side. Angle theta goes all the way around the circle. So when I see that angle theta, I should immediately think that angle is somewhere between 270 and 360 degrees. Just to give me a sense of what kind of angle I'm working with. All right, so let's use the information we're given to draw a reference triangle. So the reference angle, remember, is that acute angle located here. The reference triangle is the right triangle formed by that acute angle. All right, so there's my right triangle. There's my reference angle. All right, now, what do those x and y values tell us about our triangle? Well, the x value tells me the horizontal distance, or that base here. The y value tells me the vertical distance, or the height of that triangle, which is located here. Now, if we think about what that means in terms of trig, or trig problems, -15 is really opposite my reference angle. 8 is the adjacent side. Now, we're going to be using really an inverse trig ratio to find what that angle is. So thinking to my 3 ratios, so katoa, the angle that, or the ratio rather, that we would want to use to find that angle is going to be tangent, because I'm given information about my adjacent side and my opposite side. We don't know our angle. So my equation is going to look like this. Tangent of theta is equal to -15 over 8. All right, to solve a problem where we're trying to find the angle, we need to use the inverse tangent. So I'll do that to both sides. So on the left side, I'm left with theta equals tangent -1, or inverse tangent of -15 over 8. All right, let's turn to our calculator to calculate that angle measurement. Well, I already input it in before. So tangent -1 of -15 over 8 is -61.93 if we round to the nearest hundredth. Now, one thing we should think about here. This angle that we're given is not really theta. This is our reference angle. So what we need to do is we need to think, is this really theta? Think back to the very beginning of this problem. At the very beginning of the problem, I mentioned that theta is somewhere between 270 and 360 degrees. And this angle that we solve for actually tells us how far away we are from 360 degrees. Because this is really our acute angle that's formed by that reference angle. So to find theta, I'm going to take 360 and I'm going to subtract, let's just round that off to 62. And I'll have 298 degrees. All right, so the measure of angle theta is 298 degrees. All right, if we want to check this for like, I don't really buy it. Is the tangent of 298, is that really the same as negative 15 over 8? Well, let's try it out. Again, this sort of step is optional, but I'm hoping it will kind of prove things for us. So let's check. What is the tangent of 298? All right, well, let's turn to our calculator. So it's negative 1.88 about. And now, what is negative 15 over 8? Negative 1.87, if we round that, I may have gone too fast, negative 1.87. So if we round that, that would be negative 1.88. So those are the same. Okay, so let's just look at the second part of this problem, and then we'll go back and kind of summarize the thinking that should go on when you're solving the problems that follow. All right, so the second question says, is this a unit circle? And what is the length of the radius of circle A? All right, so I think let's go ahead and figure out what that radius is. Now, I'm going to draw that in purple. Our radius, with a big R, our radius is the same as our hypotenuse here. We could just use the Pythagorean theorem to find that. So 8 squared, I'll do in parentheses, plus negative 15 squared is equal to our radius squared. So that's 64 plus 225 is equal to our radius squared. All right, that's going to be 289 equals r squared. Therefore, our radius, solving for r, is equal to 17. All right, is it a unit circle? No, it's not. Why? Well, because the radius does not equal 1. Okay, so you can pause the video. Now let's kind of summarize what we did in the problem above. So the first thing you're going to do in the problems that follow is use inverse trig. So inverse trig is that sine -1, cosine -1, tangent -1. So use inverse trig functions to solve for our angle. Okay, the second thing we're going to want to do is we want to stop and think. Is this really theta? Is this really the angle that we're given? So remember in the problem above, when we drew theta, before we even started the problem, we decided it has to be somewhere between 270 and 360. So when I got my angle measure of -61, I had to use my unit circle to help me find the final angle. So if it's not, what we need to do is find its reference angle. So in this case, our reference angle was really that 61.93. Okay, so finally, we're going to use our reference angle to find theta. All right, so before you kind of get started on these problems yourself, if I look at the practice problems, what I would want to think about or make a prediction about is what should theta be between. So if I look at problem 1, based on where theta is, theta needs to be a measure between 90 and 180. Okay? For question 3, you're told that the terminal, or question 2 rather, the terminal side of angle theta intersects the unit circle below. Because it's a unit circle, we know the radius equals 1. Okay, so use that to help you decide, are you going to use sine, cosine, or tangent to solve this problem? And for question 3, plot that point, 2, -2, decide what does that tell me about theta. Look back at the example. All right, I'll be available for tutoring on Thursday for this, and I'll also be in class tomorrow morning to go over any questions you might have.